Okay, let's look at the general procedure for solving absolute value inequalities again. So step one is to isolate the absolute value, and I have the inequality negative 2 times open absolute value x plus 1 close absolute value plus 1 is less than negative 11. So to isolate this absolute value, the first thing I'm going to do is subtract 1 on both sides, and I have negative 2 open absolute value x plus 1 close absolute value is less than negative 12. Okay, to get it isolated, I divide both sides by negative 2, and I have open absolute value x plus 1 close absolute value. When I divided here on both sides, I had to divide by a negative, this negative 2. So that switches this inequality from less than to greater than, if you recall that from Algebra 1. And this becomes positive 6 because I have a negative divided by a negative. Okay, so I've isolated the absolute value, check. Now I'm at set up the two inequalities. If you'll notice, I have the absolute value is greater than some number, so I'm in this step B here. The absolute value of something is greater than a number. Now this step strictly tells me, okay, for the first inequality, write what you see without the absolute values. That is, write it x plus 1 is greater than 6. And then write the statement or, and then do the exact opposite with the inequality and the sign of the number. So x plus 1 is less than negative 6. And that's one way to memorize both of these statements is the first inequality you write is exactly what you see without the absolute value, and the second one you switch the inequality symbol and the sign of the number. But again, you don't have to memorize this procedure. You can go back to the geometric interpretation. I need a number in this absolute value whose distance from 0 will be greater than 6. Well, then that number, in this case x plus 1, would have to be greater than 6 in order for its distance to be greater than 6 from 0. Now, another way you could do that, instead of it being greater than 6, is if that number was less than negative 6, it would have a distance from 0 greater than 6. So you can just go back to that. I have a video on the introduction of absolute value inequalities which discuss that. But right now we're just using this procedure to solve the inequality. So I finished step 2, setting up the two inequalities. Now we're solving both of these. So I subtract 1 on both sides. X is greater than 5, or subtract 1 on both sides, x is less than negative 7. Okay, and since this is an or statement and not an and, I can't write this as a compound inequality, so this satisfies everything I need for the set builder notation at this time. Now let's look at the graphical representation. We need to graph this. Graph x is greater than 5. Well, right here is where x is equal to 5, so I'm going to put an open circle here. Because if you'll notice, it says x is greater than 5, not x is greater than or equal to. Since there's no bar underneath here, I can't have a closed circle. X is greater than 5 is all the numbers to the right of 5. Alright, and x is less than negative 7, again, open circle, and less than negative 7 is to the left. Numbers like negative 8 are less than negative 7. Okay, we've displayed the solutions using set builder and a graph. Now let's verify the solutions. In order to do that, I'm just going to check the boundary and then make sure that that boundary is reasonable. Okay, so what does that mean? Okay, I'm going to plug in 5. And what I should get over here on the left is negative 11. Now, notice 5 is not a solution, and negative 11 is not less than negative 11. But any number greater than 5 will give me a number that is less than negative 11, which will be a number like negative 12 or negative 13. So let's check the boundary. We'll plug in 5 in the verify solution section here. So I have negative 2 absolute value 5 plus 1 close absolute value plus 1 is less than negative 11. Now we know it's not going to be less than negative 11. We're just hoping it's going to be negative 11. So this is negative 2 open absolute value 6 close absolute value plus 1 is less than negative 11. This is, of course, absolute value of 6 is, of course, 6. 6 times negative 2 is negative 12, plus 1 is negative 11. Now, of course, negative 11 is not less than negative 11. And we expected that because 5 is not actually a solution to this inequality. But if I would have picked a number like 6, 6 plus 1 would have been 7. Absolute value of 7 is 7 times negative 2 is negative 14. And negative 14 plus 1 is negative 13, which is less than negative 11. So that shows that this side is a correct solution. I'll leave it to you to verify that the correct boundary here is negative 7, and that once you plug it in, you will get negative 11. And the only way to get a solution that'll satisfy this inequality is if you pick a number less than negative 7.